Now we were looking at what happens once an electron has moved to a higher energy level. We saw that emission can be either radiative or non-radiative. Now we are going to look at those two phenomena separately. We first look at spontaneous emission. Now what happens in spontaneous emission is the electron de-excites, giving out a photon of frequency nu, where E2 minus E1, the energy difference, is equal to h nu. This nu is equal to the frequency of the photon given out. So an electron in E2, without getting any further incident energy, it finds E2 too unstable for its capacity to handle, and it decides, I want to go back to E1. So it realizes I have more energy than E1 requires, so I need to give out this extra energy which I took up during absorption. So it gives out a photon. The photon has energy equal to h nu and frequency nu, where h nu is the difference between the levels E2 and E1. So this electron which is going from the higher level to the lower level, it will keep whatever energy it requires to remain in E1, and the extra energy it emits. And this emission happens without any incident radiation or any human intervention, any energy being given from our side, which is why it is called spontaneous emission. So an important characteristic of spontaneous emission is that the phase and direction of emission are random. So let's say you have 4 electrons in the higher level, and each of them one by one is going to decide to come back to the lower level. Each of them will emit a photon in a different direction, and the path taken by the electron to come from E2 to E1 is going to have a different phase. There is no uniformity or commonness, because each electron decides of its own accord. So there is no one common trigger, or it's not like you are providing some energy and the same energy is encouraging every electron to come back. It is each electron's independent decision to come back. So the direction in which it throws out a photon, the phase will be different. The only common thing will be the frequency of all photons is h nu, because E2 minus E1 is constant, it's equal to h nu. So that is spontaneous emission. The rate of spontaneous emission, again RSP, is proportional to the number density of electrons in the upper level N2, because spontaneous emission happens from N2. Whatever is present in happens from E2. Whatever is present in level E2 is only going to come down. So it depends on E2. But again, there is no energy you are providing, which is why there is no proportionality to rho nu d nu here. So RSP is equal to A21 N2, where the constant of proportionality A21 is the probability for spontaneous emission. Why probability? Again, it is not necessary that every electron chooses to come back. I mean, every electron will choose to come back at some time or the other, but it also depends upon how much energy that electron got while absorption was happening. So if an electron got more energy during absorption, it might stay there for a longer time in the higher level. Someone who got less energy might want to come back quickly. So, and there are other factors, the orientation of the electrons and so many other things. So the probability that spontaneous emission happens is it is a valid thing. Although spontaneous emission will happen, the probability that it will happen at any given time, for instance, it's not a constant, which is why we have this probability term. So finally, what is our expression? Rate of spontaneous emission is equal to A21 N2, where A21 is the probability that spontaneous emission will happen from the second level to the first, and N2 is the number density of electrons in your higher level. Also A21 is equal to 1 by tau r, where tau r is the lifetime, if you remember, which we described here, specifically the radiative decay lifetime.